So now we're on to topic 2, lesson 2. Yes, that should be a 2 right there. And we're going to talk about point slope form. Also a good form, just not my favorite. I love points, I love slope intercept. So the homework is posted in Schoology. Follow the directions in Schoology as to how to do that and when that is due. Today you will need that topic 2 packet out again today, so we're going to be using that. Get that packet out so you'll have it to refer to. It's after the grids pages. It's about on page 12. Okay, the notes start in your book on page 35. So turn to page 35, here we go. So Paul and Seth know that one point on a line is 4, 2, and the slope of the line is -5. And I've kind of already underlined some of that information, and I guess I'm going to move the line around. Each student derived an equation relating x and y. Notice what Paul used. Yes, that is slope-intercept. Okay, that's what we talked about in the last lesson. And so what he did is that he plugged in the 2 for y, the slope, and the y-intercept and solved for b and came up with an equation. That's what we did in yesterday's lesson. Well, Seth, what he did is he went all the way back to slope. And he took slope and he plugged in what the slope is. That is given. That's a -5. Okay, and he plugged in the point 2 and 4. So now then he just cleared the fraction. So what he did here is he cleared the fraction by multiplying by x minus 4 on both sides. Okay, so he multiplied by x minus 4, and that's how he came up with his equation. Okay, do the two equations represent the same line? Construct a mathematical argument to support it. Well, first, the slopes are the same. And 2, they go through the same point. And that same point happens to be 4, 2. So it's looking like they would be the equivalent equations, even though they're written differently. Okay? Now in B, we take the two equations, and what it wants us to do is to generate a table of values for each equation. How can you reconcile the tables with the equation? So what they want us to do is to make a table for each of these. We pick the x values, okay, make a table for each of these. Now if we want to see if they come out the same, let's pick the same x values. So my favorites, -1, 0, and 1. -1, I'm going to leave some room to actually do this. Okay. And over here, I'm going to do the same thing. So I'm going to make this my y values. So I'm going to use -1, 0, and 1. I'm going to plug it in. So 5 times -1. Okay, make a table, go. So just checking in on you, if I plug in -1, 0, and 1, I get 27, 22, and 17, yes? Okay, let's go over here and do this other table. Now in this table, we're going to plug in for x. Then we're going to have to kind of bring that 2 over every once in a while, aren't we? So okay, so remember you're plugging in those values. Here we go. Okay, so hold on a second. It's much easier if we actually have y by itself. So let's add 2 to both sides. So I get -5 times x minus 4 plus 2 is equal to y. So then I'm doing -5 times x minus 4 plus 2. Let's plug those values in there. So by generating a table of values, we have found out that we get the same values. When I plug in the same x values in both, I get the same y values in both, okay? So that's one way I can reconcile. I plug the same x values in, I get the same y values out. Okay, that makes sense. Now, it says, how could you represent the equations to show that they are equivalent? Well, we kind of started it right here. Look at this equation right here. We solve for y. So couldn't we just simplify what's right here? And by simplifying, I'm going to get -5x plus 20 plus 2 is equal to y. Combine like terms, I get -5x plus 22 is equal to y. So these are both linear equations, and you can see we're going to get the same thing if we simplify this one right here. Okay, good. So we're going to use what we just were dealing with, and we're going to see where point slope actually comes from. So the first thing, and if you would like to write this down, you can in the left-hand column on page 36, or you can just watch. Both of them would be fine with me. You can decide. You can always pause it and write the information down. So what we're going to start with is slope. M equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Okay? And now we're going to clear the fraction. So this is an abstract idea, but it's a literal equation. We're just going to clear the fraction. Okay, so clear this fraction. Notice my denominator. I'm going to multiply both sides by the quantity x sub 2 minus x sub 1. And when I do that, on the left-hand side, I have slope times x sub 2 minus x sub 1 is equal to y sub 2 minus y sub 1. Okay? And that is where point slope comes from. Okay, now we're going to actually write it as y sub 2 minus y sub 1 is equal to slope times x sub 2 minus x sub 1. And then we say, okay, we're only going to plug in a point and the slope. The names we have in math are not that creative. We have a point and we have a slope. So actual point slope form looks like this. Y minus y sub 1 is equal to slope times x minus x sub 1. So we replace the y sub 2 and x sub 2 with just an x and a y. Because if it's a linear equation, it has to have an x and it has to have a y. X sub 1, y sub 1, remember this is just a name. That means I'm from point 1. That's my name. Okay? So we talked about that in the last lesson. This is point slope form. And we're going to be using it. And notice the name point. So we have a point and we have a slope. Now, one of the things that I want you to pay attention to is this minus sign. It's one of those times when we actually want a subtraction sign, because then we can pull the point directly out. We can say that my point, so here we go, if I have y minus 2 is equal to 5 times x minus 7, my point is 7, because that's the x value, 2. My slope is 5. So it looks like I'm taking the opposite, but I'm not. It goes back to subtraction and what our original slope formula was that we started with. Okay? So this is point slope form. That's something you're going to want to have memorized, just like slope-intercept. So we want to understand point slope just a little bit better, and we want to practice with our y-intercept. So this says, and this is in your book, page 36, describe the steps needed to find the y-intercept of the graph using the point slope form. So let's start by writing point slope. Y minus y sub 1 is equal to the slope times x minus x sub 1. And we're going to write it often so then we can remember it. So now what we have to realize is it's saying y-intercept. What do I know about the y-intercept? Remember the y-intercept? It's where the graph crosses the y-axis. So right here, my graph is crossing the y-axis. And notice my ordered pair right there is going to be 0 for x and whatever the y value is. So if I want to find the y-intercept, describe the steps, I'm going to plug 0 in for x. Okay, so if I want to find the y-intercept, to find the y-intercept, I'm just going to plug 0 in for x. Okay, so that means that I have y minus y sub 1. I don't know my y value, but that's how I'd find my y value. Then I have slope times x minus x sub 1. Sorry, I plugged it in the wrong x. That x just hangs out there. That is just an x. I'm going to plug it in for my x coordinate of my point. Then I just simplify this and I have y minus y sub 1 is equal to slope times x, because if I take slope times 0, I just get 0. And I can get this into slope-intercept form by doing my literal equations. And what I'm going for here is that means that I want to get this y by itself, because slope-intercept is y equals mx plus b. Okay, so I could find out what that would be. I would subtract y sub 1 from both sides, and I would have y is equal to mx minus y sub 1. So that would give me what my y-intercept is. Whoops. What my y-intercept is. Right here, y sub 1. Okay? Kind of an abstract idea. Don't worry about it too much. But just always remember, if I want to find my y-intercept, I'm always going to plug 0 in for x. Good. Let's just get back to the basics for a little bit. They want us to write the equation in point-slope form that passes through the given point and has this for a slope. So the first thing, of course, we do is we write down slope-intercept form. Sorry, point-slope form. Y minus y sub 1 is equal to slope times x minus x sub 1. Okay, now let's plug in what we know. This is x sub 1, this is y sub 1, this is m. Yes? Good, let's plug it in. Y minus 5 is equal to negative 3 times the quantity x minus x sub 1. Okay, now remember, look at this again. Those are both positive numbers, and when I plug them in, I want subtraction. It's kind of a weird thing. Okay, so let's try the next one. Okay, so this one is one step again. We're going to find it in point slope form, so y minus y sub 1 is equal to slope times x minus x sub 1. Okay, so say it says write the equation that passes through these points. Okay, so look at this. We have points. Boy, we have 2 points. We're overabundant with points. Do we have the slope? No, but can we find it? That's right, we sure can. We can find slope by subtracting y over subtracting x. So take negative 1 minus 3 over 2 minus negative 3. Subtract, and we get negative 4 over 5. Okay, that's our slope that we're going to be using. So now we have a slope. Yay, there's our slope. I keep on moving the circle around. Now we have to have a point. A point. That is so fun, isn't it? So a point. We have 2. Doesn't matter which one we pick. It does not. Not at all. And if you were in the room with me, I would have you decide. But since you're not, I'm going to decide. So we're going to take the point, and we're going to take the slope, and we're going to plug it in. So here we go. So we have y minus, and the slope, okay, and we're going to plug it in. So we're plugging in all those other points. So we plugged in the slope already. Now we're going to plug in our y value. That's a negative 1. Don't worry about it. Okay, we're going to get there. Don't worry about that right now. And then minus our x value, which is 2. This is the equation in point slope form. We just clean it up a bit because we have minus and negative. That's going to be a plus 1. And then negative 4/5 x times the quantity x minus 2. So we have our equation in point slope form. And if that's all I want us to do, that's where we would stop. There's going to be some problems where they have us get it into slope-intercept form. So we will work on that too. You know what? It never hurts, so let's do it. So now what we're going to do is we're going to get it into slope-intercept form. What's slope-intercept? Y is equal to mx plus b. Okay? So if we get it into this form, notice I just have to get y by itself. So I'm going to get y by itself. So let's just kind of clean up the sides. We already kind of cleaned up the left-hand side. Now let's distribute on the right-hand side. We have negative 4/5 x plus 8/5. Let it hang out for now. Okay, we'll get to it. Now we want to subtract 1 from both sides. So we get y is equal to negative 4/5 x. And then you can do it on your calculator. I'm going to put this as 5 over 5. And I'm subtracting that. So I'm going to get 3/5. So 8/5, I'm taking 8/5 plus a negative 5/5 because that's equivalent to 1. So I get 3/5. You might have done that on your calculator. Okay, that's my equation in slope-intercept form. This is my equation, or this is my equation in point-slope form. Good, let's do another. Now this time they're very specific. They just want us to get it to be in point-slope form. So that's all we're going to do. Notice where I'm at, page 38, number 7. Page 38 in your book. So here we go. What's the first thing we have to do? That's right. We have plenty of points. We need a slope. So let's go through and find slope. Go. Did you get a slope of negative 4/3? Awesome. Now which point do you want? It doesn't matter exactly. So pick a point. Okay. You pick a point, I pick a point. Let's compare. Go. Recommendation, write down slope-intercept form first. Okay, write down point-slope form first. Write down point-slope form first. And then plug it in. Go. So if you plugged in 4/2, this is your equation. And if you plugged in 1/6, this is your equation. And if all I want is point slope, I'm done. Yay! Now we're going to sketch using point slope. Okay, we're going to draw a line. So the first thing we need to do is that we need to have an axis and just draw it kind of in the middle there. It doesn't really matter that much. We're going to draw in an axis. Okay, now we're going to plot our points. So our point, think about it, what is our point? Remember slope-intercept form, y minus y sub 1 is equal to slope times x minus x sub 1. So my point is going to be right there. Now my x value, that one's 3. What's my y value? Think carefully. Remember, we want subtraction, so what is that point? Good, -2. That is my point. My slope, of course, is just going to be this 1/2. Okay, so I'm going to plot my point, 3, 1, 2, 3. So I want 1, 2, 3, and down 2. So here's my point. Now I'm going to use my slope, and I am going to go up 1, because my top number is 1, and over 2. Okay, now I can go the opposite and go over 2. It doesn't make any difference. So this is going to be my line when I connect these points. Okay, there's my line. That's all there is to it. So it's the same as graphing with slope-intercept, except for you're given a point instead of the y-intercept. Everything else is the same. So now you need to go to your additional packet, page 12, and we're going to do some more of these. So let's identify what is the point and what is the slope. So what's the point? Well, here we go. Let's write down point slope form again. Y minus y sub 1 is equal to slope times, I'm going to put this in black so we can see it better. Y minus y sub 1 is equal to slope times x minus x sub 1. Okay, so what is my point? Well, if I have minus, I pull it straight out. I have a minus right here. So that means it's going to be my y value is just 5. Now over here I have a plus sign, so I actually have to take the opposite of 3, so that's a -3. Pause, refresh over that, rewind over it if you need to, and listen to that again. So now my slope is 2. And remember, slope is a one-time you want a fraction, so read it right as a fraction. So let's plot that. I'm going to go -3, +5. Then I'm going to use my slope and go up 2 over 1, down 2 over 1. Bam, I am done. Graphing is so awesome with slope, isn't it? It's just fun. Okay, look at number 2. What I want you to do is I want you to write down what is the point and what is the slope. Try that on your own. Go. So slope, no problem. -1/4. We got that. What's my point? Okay, look at my 1. Look at my equation. Look at my form. Not formula, form. Look at my form. So my x value is a -1. I need the opposite. Look at my y value. Again, we want subtraction. We don't have it, so we know this needs to be an opposite. So my point is -1, -2, and I have a slope of -1/4. Wow, lots of negatives. So I'm going to go -1, -2. There's my point. Now I'm going to use my slope, and I'm going to go down 1, 4 to the right. And I'm going to go up 1, 4 to the left. Did I count that? 1, 2, 3, 4. There we go. So there is the graph of my line. Oops. Okay. Hopefully that helps some. Good. We're back on page 38 now. So go back to page 38. And now we're going to write the equation given a graph. Okay. Again, write down slope. Write down point slope form. Write down point slope form. Go. So my form is y minus y sub 1 is equal to m times the quantity x minus x sub 1. Now we need a point. What is our point? Well, it's 2, -1. Yay. What is our slope? Okay, we have a point. So look for whole number points. I see one here. I see one there. So what's my slope? I go down 2. So down 2 over 1 to the right. So it's -2 over 1. So here we go. We're going to plug in all of our stuff that we just learned. So in place of slope, I'm going to use a -2. My y value is -1. Just plug it in. Don't worry about it. Just plug it in. Okay? And then we're going to plug in our x value. What's our x value? 2. So x minus 2. So if I want to write the equation in point slope form, I am done technically. Usually we write it one more time just to clean this side up. So y plus 1 is equal to -2 times x minus 2. Both of these are right. This is probably the answer that we would write. It just looks a little neater. Good. These habits of mine are actually kind of good. They make us think without too many other things. So it says, explain why the equation of a vertical line cannot be written in point slope form. So let's think about a vertical line. Here's our vertical line. Okay. What do we know about a vertical line? Vertical line is undefined. So the slope is undefined. Okay. So think about now point slope form. Y minus y sub 1 is equal to slope times x minus x sub 1. Well, how the heck are you going to plug in an m that's undefined? If we can't define it, we can't plug it in. So there's our problem. Our slope is undefined. Slope is undefined. Okay, so if our slope is undefined, we cannot write an undefined number because it's not defined. Okay, so it would be something over 0, which is undefined. Good. Now what we're going to do, this is something very common. I'm on the additional packets page 13 now. Go to the additional packets page 13, and you can do these right along with me. Okay, so we have to get the equation in slope-intercept form. Let's look at slope-intercept form again. Y is equal to mx plus b. And this goes back to that whole point of literal equations. Remember when we have to get y all by itself? So that's what we're going for. We're going to get y all by itself. So here we go. Are you ready? What's your mind saying you should do first? I'm guessing it's saying please distribute. Please distribute. So we get y minus 2, that hangs out, and then we're going to distribute right here. 4x minus 36. Now we're going to get, again, we want to get that y by itself. That's our goal, so we can have slope-intercept form. So we're going to move the 2 by adding 2 to both sides. So we get y is equal to 4x minus 34. Okay? So if I'm getting an equation in slope-intercept form, I'm going to probably plug it into point slope form. That's my favorite way of getting it into slope-intercept form, is plugging it in. Okay, you're going to try number 4. Go. Remember, you're solving for y. Try to get y by itself. Go. So hopefully you've tried number 4 and you've gotten y by itself. I'm just going to go through the steps with you as to what's going to happen. So the first thing you're going to do is distribute on that right-hand side. Then you want to get y by itself, so you're going to subtract 1 from both sides. And we get y is equal to 3x plus 11. Nothing difficult, we just have to pay attention to the details. Good. Now we're going to look at the additional packet again on page 13. We haven't left it. Okay, this is example number 4. Now you have this, try it in your book and it says in example 4. Well, it doesn't make sense unless you have example 4. So let's look at example 4. An event facility has a banquet hall that can hold up to 250 people. The price for a party includes the cost of the room rental plus the cost of a meal for each guest. Marissa is planning an event for 75 people. She has a budget of $1,200 for the party. Will it be enough? So let's just look at what's going on. Okay, our x value, our x-axis is the number of guests. So if I have 50, 100, 150, okay? And my total cost, I'm talking about cost over on the y-axis, goes up 0, 500, 1,005, okay? So if I look at this particular point right here, this is the point 50 guests. It costs $725, okay? If I wanted to go to another point, and I can pick any one I want, I'm going to go to 100. Oh no, let's just do 200. So this is the point 200, and the cost is $2,525. And I can choose any that I want, but these are just points on my graph. And see how they're a linear function? Okay? So she says she has budgeted $1,200 for the party. Is that enough for 75 people? Oh, look at that tricky thing. We don't have 75, so we're going to have to find that out. So what we're going to do is we're going to find the equation of this line, and then we're going to plug it in and plug in 75 to see if it's enough. Okay, so take any 2 points. If I'm going to actually do this, I would probably use this point right here because I like 100, but it doesn't really matter. I have these two written down. I'm going to go with that. So let's first find slope. So subtract y over subtract x. So you're going to take 25 minus 725 all over 200 minus 50. What's my slope? Go. Okay, so my slope is 12. Let's just think about that for a second. My slope, remember, is y over x. So that means the cost is $12 per one guest. Okay, that's my slope, just to let you know. Now, what we're going to do is we're going to plug it in. I'm going to plug it into, well, it doesn't matter. Do you want point slope or slope intercept? Which one should we pick? Which one should we pick? I'm going to pick point slope. So I'm going to take this point and this slope and go. Okay, so I have y minus y sub 1 is equal to the slope times x minus x sub 1. So I have y minus my y value, 725, is equal to the slope times x minus the x value. Okay, that's my equation. Now, what we have to realize, I can have it in point slope, I can change it to slope intercept. It really doesn't matter which one I'm going to use. What they're asking about is we have 75 people. Is $1,200 going to be enough? So in other words, if I have an x value of 75, that's my x, is my y value going to be 1,200 or less? Okay, so let's plug it in. Y minus 725 is equal to 12 times 75 minus 50. Okay, so we just found out that if my x value is 75, which is what they're asking about up here, my y value would be 1,000. My cost, because cost is y, my cost would be $1,025. If I budgeted 1,200, did I make it? Yes, you did. Good. Okay, now rewrite the point slope form equation from example 1 in slope intercept. What does a y-intercept represent in terms of this situation? Okay, so I hope you have this all written down because I'm going to pause and I'm going to erase from here on down. Okay, so if you don't have it, you might want to write it down or else you're just going to rewind. So they wanted me to take my equation that's in point slope form, rewrite it into slope intercept. So that means I have to get y by itself is what I'm heading towards. Okay, so let's clean up our sides and go. Okay, so bring that 725 over. I've cleaned up my sides, I've distributed, so I'm going to add 725 to both sides. So my equation turns out to be 12x plus 125. Okay? So what does that mean now? They ask us, what does the y-intercept? So they're asking, what does that y-intercept, what does this number represent? Well, if my y-intercept is going to come down here, okay, so here's my line, right, on my graph. My y-intercept comes down here. So my cost is going to be $125 even if there are no people, because my y-intercept, remember, is 0, whatever my y value is. My y-intercept is 125, so that is the point, 0, 125. So what does that mean? It means that it's going to cost $125 even if I have 0 guests. So that's going to be an initial amount no matter what. Good. This habits of the mind, I'm actually starting to like these a lot because it makes us stop and think, oh yeah. Okay, so when is it appropriate to write the equation of a line in point slope rather than in slope intercept? Don't overthink this. When would it be appropriate? Well, if I have a point and I have a slope, I'm going to use slope intercept. I'm going to use point slope form. So if I'm given a point and the slope, or if I'm given 2 points, I can then use those 2 points to find the slope and then choose one of the points and find my equation. Slope intercept, I have to be given, well, point slope, I could still find the equation. Point slope is going to be a little easier. I don't have to, here I'd have to solve for b. Okay, good. Now we're on page 38. Do you understand? What information does a point slope form of a linear equation reveal about a line? It reveals the point and the slope. So it reveals the slope and a point. Not a whole bunch, just a point on the graph. Number 2, if you know a point on the line and a slope of the line, if you know a point and I know the slope, so if I have a graph and I know the point and I know the slope, how can you find another point on the line? Exactly. Use the slope. Okay? So you're going to first plot a point. So plot the point and then use the slope by moving, remember, top number goes up and down, bottom number goes left and right. Use the slope to find another point. So if I have a point plotted and I know the slope, I can count up and find another point. So I can count up and over, down and over, whatever. I like when we do error analysis. This is good for our brain. Danzel identified 3, 2 as a point on the line y minus 2 is equal to 2/3 times x plus 3. What is the error that Danzel made? Okay, first thing you want to do is write down point slope. Y minus y sub 1 is equal to slope times x minus x sub 1. Okay, write that down. Think about it. Go. I'd love to hear your thoughts right now, but I cannot do that through the computer. So we know that we have the point 3, 2. We know that if we plug it in, it's y minus the y value is equal to the slope times x minus the x value, right? So if I have both of these are positives, it's going to look like they're both negatives when I go to write the equation. And that's where the mistake comes in. He did this right, but he used the wrong sign here. Okay? He didn't remember that if both my signs have to go opposite, it looks like they're going opposite in the equation. Number 4, you know the slope and one point on a line that is not the y-intercept. Why might you write the equation in point slope form instead of slope intercept? Because you're given a point and you're given a slope. So use what you're given. You are given a point and a slope. I sound like a robot. You are given a point and a slope, then use point slope form. So we're still on page 38. We're looking at number 6 and number 8. We're going to write the equation in point slope form. So write down point slope form, plug it in for both of these. Go. So we wrote down point slope form. Number 6, plug it in, okay? And then you're done once you have it in point slope form. So if I plug it directly in, 3 goes in for y, x is -4, and my slope comes right down here. Now, I would recommend cleaning it up, so y minus 3 is equal to 2 times x plus 4. And all they wanted was point slope form. You're done. Good. Think about number 8. What's the first thing you're going to have to do there? And do it. Did you get a slope of -4, 3? Good. Now, does it matter which point you pick? Nope. Go. So if you picked -2, 8, one of your equations could look like this. And if you picked 7, -4, your equations look like this. And you might be thinking, but how do I know if these are the same equations? They don't look the same. You would have to get them into slope-intercept. And that's the one advantage with slope-intercept. You can compare much easier. So if you have these in slope-intercept, you would see they would give you all the same equation. So here's your last one. You're ready. Write the equation in point-slope form. I would recommend writing down point-slope form first and then going for the information. So did you write point-slope form? Good. Now take that information and plug it in. Look at your graph. Go. So hopefully you had some time and you actually tried that one. What we're looking at here is that this is our point. That's the easy one. We have to find a slope. So what are our points? Here's a whole number point and here's a whole number point. So you're going to find your slope. I'm going to go down 2. And I'm going to go to the left. 1, 2, 3. So I get a slope of 2/3. Okay, that's my slope. This is my point. Plug it in, go. So in place of y, I plugged in the 1 because that's my y value. In place of x, I plugged in the 3 because that's my x value. And then this, of course, is my slope. This one's already cleaned up. That's my answer. Yay! Okay, great. Now go work on your homework. Thanks.